If you're building an autonomous AI agent, you hit a wall the moment it needs to interact with the real world. Simultaneously connecting your agent to platforms like Stripe, HubSpot, and Slack requires a constant data stream. Developers write endless custom API glue code, but managing containers and fighting errors ends up choking the pathways between your tools and your AI. The industry built the Model Context Protocol, or MCP, to fix this. It acts as a standardized bridge between AI models and external data. This diagram illustrates how MCP replaces custom APIs with a universal language. Instead of a dozen different authentications, your AI speaks to any data source through one clean standard. But the protocol is only half the solution. Finding, hosting, and keeping these specific MCP servers running securely demands serious infrastructure work. By adopting the standard, you remove custom API friction, but take on massive server maintenance. The deployment process grinds to a halt. Vinkius was built to host that infrastructure. Available at Vinkius.com, it operates as a fully managed zero-trust MCP gateway. This animation shows the scale of the Vinkius platform. Over 2,500 ready-to-use MCP servers funnel directly into a single, unified endpoint. If your agent needs to read billing history, search the directory for the Stripe server and attach it to your gateway with a single click. A process that used to require a multi-week integration sprint drops to a sub-minute deployment. Plugging in public tools is straightforward. Pointing an autonomous agent at highly sensitive custom internal data, like your company's ERP, introduces serious security risks. Exposing raw internal databases to an AI without strict governance invites disastrous leaks. Speed means nothing if the system isn't secure. This is where Vurb.ts comes in. It's the open-source foundation of Vinkius. Instead of coding your own secure MCP server, you write a prompt, and your AI writes a production-ready server for you. This diagram demonstrates schema-as-firewall. Undeclared database fields are physically sheared off, ensuring internal flags are discarded before touching the LLM. For data that passes through, Vurb uses compiled PII redaction. Sensitive strings are locked into cryptographic files at config time, running with zero overhead. Data leaks are only half the threat. Autonomous agents often hallucinate, attempting to call tools out of sequence, like checking out an empty cart. Vurb.ts prevents this through a mechanic called protocol vanishing, which integrates strict state machines directly into the tool availability logic. Look at this command list. When the system state shifts from a shopping cart to the checkout phase, the Add to Cart tool dissolves completely. If the AI cannot see the tool, it is physically impossible for it to make a bad call. These mechanics guarantee enterprise-grade SOC 2 compliance, as well as GDPR and HIPAA readiness right out of the box. True AI governance requires engineering an environment where the agent physically cannot see or execute unauthorized actions. Taking this governed architecture live takes exactly one terminal command, Vurb deploy. This visualizes the telecom-grade orchestration running on the Vinkius gateway. Specialized AI agents securely pass complex tasks to one another within a swarm environment. That federated handoff relies on secure HMAC delegation tokens, and developers can implement it in just 3 lines of code. You bypass the infrastructure maintenance, lock down data access at the compilation stage, and tightly control the exact actions your agents can take. Vinkius provides the missing layer required to safely bridge autonomous models and enterprise data. To build a governed, zero-trust architecture for your AI application, visit Vinkius.com and deploy your first server today.